Okay, good afternoon. Hello. So I serve as the Extension Vegetable Specialist as well as a professor at New Mexico State University. And today I'm going to talk about the history of a lot of work that I've done, my colleagues have done in advancing mechanization of our iconic crop, New Mexico type green chili. So now, first of all, I'm going to say up front, I know that we don't produce nearly as much chili as Thailand does, as many of the countries in this region do. You are all passionate about chili. In fact, everyone here is passionate about chili. But in the United States, New Mexico, that is our heart and soul of chili peppers in the United States. So for those of you who aren't familiar with New Mexico, it's sandwiched here between Arizona and Texas. And as with many of the countries here in this part of the world, chili peppers are entwined with our cultural heritage. It's part of our heart and soul. Chili was proclaimed the official state vegetable in New Mexico back in 1965. And we were the very first state to have an official question. And that question was red or green. And that corresponded with, do people prefer red chili or green chili with their lunch? As early as recent, that is, as 2023, the state legislature named the smell of roasting green chili as the official state aroma. So we're now also the very first state to have an official smell. And of course, it has been cultivated in that part of the world for more than 400 years. So chili peppers have been grown in various pockets throughout New Mexico for a very long time. We have many land races that are associated with different parts of the state. Now, the New Mexico pod type chili, though, is quite distinct. So this pod type was originally developed by Fabian Garcia. He was in the very first graduating class of what is now New Mexico State University. And after he graduated, he became the very first head of the Ag Science Center. Now, he saw all these various land races, different pod shapes, different colors, different heat levels, and thought, if through selective breeding, I can come up with a pod that's more standardized, maybe slightly milder, that would appeal to a wider range of consumers. And by doing that, after years of selective breeding, he developed New Mexico number 9. So New Mexico number 9 was the very first New Mexico pod type chili. And I do have to say that oftentimes New Mexico chili is referred to as hatch chili. How many of you have heard of hatch chili? Maybe not as much in this part of the world. But hatch chili is actually just a New Mexico type chili that is grown in the Hatch region, which is a very productive area of farmland. We have water from the Rio Grande River. Anaheim chili is another thing. It's often incorrectly referred to as Anaheim chili. And I'll put out there right now that Anaheim chili actually had its origins in the work that Fabian Garcia was doing. He was visited by a gentleman named Gilberto Ortega when he was doing his breeding work. Mr. Ortega loved these chili peppers that Fabian Garcia was working on, so he took some seed back to California, developed the Anaheim type there, and ever since then, New Mexico is missing out on credit California is getting for the genetics that originated in New Mexico. So the red or green state question corresponds to red and green chili, and in New Mexico, we have two distinct industries for either the red dried chili product or the green succulent product. So I think we all know that chili peppers, red or green, no matter the pod type, the variety, it's a very labor-intensive crop. It takes a lot of work to plant, to maintain the fields, and certainly to harvest the chili pepper fields. And labor is getting increasingly more scarce. In the United States, we've often had years where green chili fields would go unpicked because there just were not enough hand laborers available at the time to get the crop out of the field. We also know that labor is increasingly expensive as minimum wage has gone up. My colleagues in the Ag Econ department have determined that more than 50% of the total production costs go to labor in a hand harvest system. This is reduced down to approximately 11% of overall costs in a mechanized system. So, of course, mechanization is a key method to sustain chili production profitably. Now, labor has been an issue for a long time, though, not just recently. Back at World War II, when farms lost all their able-bodied laborers who went off to fight in the war, the Bracero program was initiated. This was a guest worker program that mainly brought hand laborers from Mexico. They paid them wages, they sheltered them, gave them everything they needed to eat, health care. This Bracero program was originally supposed to end in 1947, and growers and industry just panicked. They said, oh my goodness, we're going to lose all our laborers. They're all going to go back to their home countries. So this created a very strong demand for mechanization research in the 1950s and 1960s. In fact, New Mexico was right up there at the forefront in the United States at this time. In 1965, Ernest Riggs, who was the plant manager of a red chili processing plant known as Cal Compact, took a hay rake, put it through a red chili field to see how it would do. It made the local newspaper, so it was the very first recorded mechanical harvest of chili in the press. In 1971, Wendell Krieger, who I met many years ago, who's pictured here, got the very first patent on a helix picking head for chili peppers, and pictured also as one of his very first machines. So these were vertical helicy picking heads. Now, the U.S. government dried up funding for mechanization research following the successful 1978 lawsuit against the University of California for their mechanical lettuce harvesting efforts. And chili mechanization research at New Mexico State University virtually stopped. In fact, I always like to tell the story. When I went back to graduate school and wanted to work on chili mechanization, I was told it was a non-project. So I worked on phytophthora resistance instead for my master's. For my PhD, though, I worked on mechanization, again, since I was self-funded at that time. So fortunately, growers and private industry continued the work. And chili, this was right about the time in the 1980s and 1990s where consumers in the United States were discovering chili peppers. You know, we had Taco Bell, we had Mexican restaurants coming into popular play, and boy, people just really learned to love chili. I think we all know the more we eat chili, the more people experience chili, the more they want to eat. So acreage in New Mexico just boomed, and we peaked at about 35,000 acres during this time. Then NAFTA, the North American Free Trade Agreement hit. It eliminated tariffs on imported chili peppers and immediately impacted production in New Mexico as growers, processors could bring in cheaper material from other countries. And in recent years, I will say our production has stabilized to about 8,000 to 9,000 acres produced per year for chili. So, of course, the growers, the processing plants didn't like this turn of events. They wanted to reclaim and expand chili acreage in New Mexico to meet this growing demand that continues for chili peppers by consumers. So this group reached out to New Mexico State University. In a response to this request, New Mexico State University formed the Chili Task Force. This took place in 1998. It was a collaboration between growers, industry, agricultural engineers, physiologists, breeders, and they all came forward to work on the key issues that the chili pepper industry needed to address to succeed and further their successful run. So this was critical to mechanization because, of course, chili mechanization, chili mechanical harvest was one of the key topics that needed to be researched and addressed. So this got research going again in chili mechanization after our lull. Red chili, our red chili industry was an early focus of the chili task force work. And with their help, as well as with a lot of effort from growers and industry, red chili in New Mexico is currently virtually almost all mechanically harvested. So with our red chili, it's typically a dried product. It's harvested just once at the very end of the season when virtually all of the pods on the plants have turned red. Green chili, however, our New Mexico green chili, is currently still mostly hand harvested. A very, very labor-intensive process. So green chili differs from our red chili crop in that we harvest it when the fruit are fully sized but physiologically immature, otherwise known as horticulturally mature. Growers really need to get at least 2 harvests off of their field for profitability's sake. So it's a 2-harvest crop typically. With our green chili, very thick-meated, thick pericarp, large undamaged fruit are what we're looking for. That's the optimum quality for this crop. And more than 80% of our New Mexico green chili in the state goes for commercial processing. So the commercial processors will take the bins of chili, they steam peel them to remove the outer cuticle, and the product coming in must be destemmed. And when I'm talking about destemmed, I'm talking about removal of the pedicel. So we all know in our green crop, if the pedicel material gets through the processing procedure, it becomes very woody. People bite into it when they eat chopped chili or salsa. It's a quality concern. It's a safety concern. In hand harvest fields, the laborers will pop that pedicel off in the field and then just get the bins of destemmed chili to send to the processing plants. So mechanization is obviously critical to sustaining and increasing New Mexico green chili production. We have many current advances. We have come a long, long way, I'm happy to say. However, this has been a work by many researchers, not just myself, many of the Chili Task Force colleagues I had back in the day. Challenges remain, though, and research efforts continue in the questions we haven't quite answered yet. So for this whole process, these were basically the steps we took to look into mechanizing New Mexico green chili. Number 1, machines. So first of all, do we have commercial machines that will already harvest New Mexico green chili very efficiently? 2 are cultivars or varieties that are out there. Do we have any New Mexico chili varieties that already pick very, very well that we can use in this new system? If so, or if not, we need to determine what are the key traits of these varieties that make them more efficient for mechanical harvest. Second, breeding. Do we need to improve these varieties through selective breeding to make them better for a mechanized system? And finally, after all of this, field management, field protocols are also critical. Depending on how we actually grow that crop is going to also affect how well it mechanically harvests. So number 1, machine evaluation. Now, we did look at tomato harvesters early on. For those of you who are not familiar with the tomato harvesters, they come through and they'll cut the plants off at the base. Then they go through a series of shakers and shake the fruit off. We found it just didn't work for New Mexico green chili. It is currently being used very successfully for bell peppers and other specialty peppers. And depending on the type of peppers you're working with, this may be exactly the machine you need. It didn't work for us, however. So I really want to say strongly that the machine that you use needs to work with your particular crop, the plant architecture, the way your particular chili peppers set fruit and detach fruit. So we already knew inclined double helix picking heads have been widely adopted for our red chili crop. So these harvesters and other experimental picking heads were evaluated in New Mexico green chili fields. So did the harvesters that were already being used for red chili also work well for green chili? So the 3 main types of harvesters that were being used at the time, and they're still in use, include the base chili harvester. This is another inclined double helix. The McClendon Peter Piper pepper harvester was a helical machine. And then the pick-right pepper harvester actually brushes chili peppers. So with that particular machine, it had the advantage or disadvantage of it would actually sweep fruit that had fallen onto the ground. So it's great as far as collecting yield, but terrible as far as collecting dirt clods and rocks and other material. But the growers did have that option and do have the option with the pick-right pepper harvester. In addition, my colleagues at the Cotton Ginning Research Lab, which was a USDA ARS lab, fabricated some other picking machine concepts. So one included the disc finger, and the chain finger. Both of these machines used chicken pluckers, the rubber fingers that pluck chickens, and just would sweep these through the chili plants. So we tested these in various commercial fields, and oh my goodness, we left more than half of the harvest in the field. so the chicken plucking fingers are way too gentle to get all of those chili peppers off of the plant. Obviously, growers are not going to be too happy if they're only harvesting 40% of their yield. And in addition, 17% of the fruit in the disc finger were damaged. Almost 40% of the chain finger fruit were damaged. Way too high of a damage rate and very unacceptable. They also fabricated the Hernandez head, which was brushes. So stiff brushes would go through and brush the plants to collect the chili fruit. The Krager was based on Wendell Krager's original machine, which was a vertical helical picking head. We put these machines through some commercial chili fields, and pretty close, so we got over 80% of the chili peppers that were in the field collected. However, oh my goodness, 48% damage and 49% damage, not good at all. So things started out a little bit roughly with this, but in the meantime, some of my colleagues in the Chili Task Force heard about this wonderful machine that had been invented in Israel. So a delegation from the Chili Task Force went to Israel to see this machine in action, and they liked what they saw, so we got a commercial machine back to New Mexico to run through green chili fields. And this was the young Edgar at the time. I know since then, Elad, who is here in the audience, now has his own company, so it's Edgar now instead of the young Edgar. This machine was amazing compared to all our prototypes that we had tried. So 88% of the fruit that was in the field were harvested, 11% broken fruit. Not great, but almost to the 5% level that growers were telling us was acceptable. So we thought, yeah, this is the machine we're going to go with. The problem when you have a commercial-sized machine, though, and you're trying to do plot work, it's really hard because you need such large fields to actually get any replicated data collected. So the young Edgar, the Edgar picking head, the Moses, was by far provided the highest yield of marketable undamaged green chili fruit. We took this machine in many commercial fields and we tore the heck out of a lot of New Mexico green chili fields. Not because the machine wasn't doing well, but because the varieties were not right for mechanization. So we could immediately see that the varieties also needed some work. So in 2014, with Elad's help, New Mexico State University purchased a small plot, one-row, tractor-powered harvester. And once we had this harvester, we could do all kinds of replicated work on both commercial varieties, on breeding lines, as well as field protocols that we could test at our various ag science centers. This allowed us to tear up our own fields. So growers were happy, we were happy. The mechanization research was on track. So looking at commercial chili cultivars, so many challenges, fruit damage. Are we getting too much fruit damage with this variety? Is a second pick possible? As I mentioned, growers count on that second pick to get the profitability out of their field. Are we leaving too much in the field? Are we harvesting too much trash? Is there too much sticks and other debris in that material? And destemming. So destemming, if we don't have hand laborers popping those pedestals off in the field, we're going to need some way to have those fruit destemmed before they get to the processing plant. So our currently available New Mexico green chili cultivar is optimum for mechanical harvest. So we looked at many different breeding lines, commercial cultivars, and I don't have the data here, but I will say we had major differences in the efficiency that different varieties would harvest. And after looking at everything, it seemed that New Mex Joe Parker, which was released by Paul Boslin at New Mexico State University, by far was the best. So it gave us a pretty good mechanical harvest result, especially with our Edgar machine. So what traits are important then for a good mechanical harvest variety? Well, we initiated the breeding program, and these are just a short list of some of the different traits that we measured. So first of all, we know that easy and efficient destemming is important, so that's something we looked at, but also the plant height, width, how high is the fruit set, that primary bifurcation, how wide, what's the stem diameter, a number of basal branches. When I talk about basal, I'm talking about these branches that come out below that main bifurcation. Distance between internodes, how compact is that plant setting its fruit? Determinacy, there's a nice determinate plant that's going to give us a nice once-over pick. Fruit orientation on the plant, are the fruit on the outside of the canopy? Are they tied up in those stems? And also well-rooted, resistant to lodging and uprooting is really important. Whenever the machine would uproot a plant, the whole product flow would just kind of have a train wreck, crash, burp, and we'd have a real mess on our hands. So I will quickly mention considerations for mechanical destemming. Now, I know the next speaker was supposed to be someone I've worked with for a long time who's working on a mechanical destemmer, and we have several different concepts that are in play right now. I don't know what method industry is going to settle on, but depending on how we're mechanically destemming the fruit, uniform straight fruit may be important if those fruit need to lay in a conveyor belt. Long pedicels, if it's a machine that's going to grab those pedicels to pull them off. Efficient destemming, we don't want the stems or pedicels to break during this process. And easy destemming, if we can get these pedicels that will detach from the fruit so easily that during harvest they're left on the plants in the field, then that's perfect. That's perfection. We would love to see that. Now, so of course the force to remove the pedicel from the fruit is the destemming force. To just get them harvested, of course, the abscission zone right there where the pedicel attaches to the plant is important, but to leave those pedicels in the field, the fruit to the pedicel abscission zone is important. And I guess I will say that so in hand harvested systems, this is easy. The people do it. If we're going to do it mechanically, the pedicels can be cut off or pulled off. Cutting off is easy. Obviously putting the peppers through a knife or a water knife that's going to remove those pedicels is great. But if you do that, number one, you're losing a lot of yield that goes to the processing plant. And secondly, those fruit degrade very, very quickly once they're cut. So I've always been a proponent of the pulling off method. The problem is it's very slow to do this right now. So this is an area of research that's still very actively in play. So the pedicel shape and size are critical, and they need to optimally match with a particular type of mechanical destemmer. And pedicel integrity is also important. We found certain varieties, the pedicels just break, and in others, the pedicels stay intact and can be removed very efficiently. So we did, for many years, we did look at that pedicel removal force by hand, but in 2018, I'm happy to say we began a collaboration with UC Davis. Dr. Van Dynes is here in the audience, and we adopted their method that they had developed using a Tonichi torque meter to measure the destemming force to remove those pedicels. They also identified land races that had very, very easy pedicel removal. So these were very interesting varieties with this genetics that had easy pedicels. We put these lines in our yearly mechanical harvest trials at New Mexico State University. We found that they had smaller fruit, about the size of a serrano to jalapeno. They were big, bushy plants, so they didn't really have the architecture for mechanical harvest. But my goodness, when we put these through, 40% of these fruit were harvested destemmed. So this was compared to our typical New Mexico lines that we'd have maybe, if we were lucky, 1% destemmed fruits harvested through the mechanical harvest process. So this was a huge find. And I know that UC Davis is currently working on developing breeding lines that are easy destemming. We also have breeding lines that we're looking for real easy destemming. But let's get back to the plant architecture, though, quickly. So as I said, we measured many different traits to determine which were key for mechanical harvest efficiency. What traits do we really need to select for in our breeding program? And these were the three that we found strong, significant difference in. Number one, we want more of the strong single stem plants with fewer basal branches. This is one of our breeding lines right here. You can see those fruit are right there on that single stem. The fruit set a little bit higher, so we don't want them ridiculously high where those plants are going to topple over, but just getting those fruit well off of the ground, because we did find that the machines tend to run over and crunch any low-lying fruit. So we're trying to breed away from that. And the final magic trait was a somewhat easier fruit detachment from the plant. So we found that many varieties, if they held the fruit on very, very tight, it would cause the plants to just be picked up and pulled out of the ground by the machine. So in 2021, my program released New Mex Odyssey. This variety had these three key traits associated with it. It's an open pollinated New Mexico type green chili, and it has consistently given us the highest marketable green fruit yield with inclined double helix harvesters. And it's a mild heat, great New Mexico flavor. We leave very, very few fruit on the plant, very low level of fruit damage. We do get a second harvest off of these after they've been mechanically harvested. And I will say, I'm very proud to say this whole title of my talk. In 2023, we did have our first year of commercially processed, mechanically harvested New Mex green chili using New Mex Odyssey. Very proud moment for New Mexico State University and my program. And in the interest of time, I'm going to skip over some of the field management, which is very, very different than most of the folks here in the audience's field management would be anyway. We are working on releasing additional mechanically harvest-efficient cultivars, as well as putting disease resistance for key diseases in New Mexico into these varieties. Oops. And finally, our currently remaining challenges to mechanization. We really need those high throughput and economical mechanical destemming machines. And of course, our growers need to have access to both the harvest equipment as well as the destemming equipment. So challenges remain. Mechanical harvest adoption remains essential, though, for long-term industry growth and sustainability, not just in the United States, but I will say throughout the world. Yeah, here's many of the people who have supported this research. And with that, this is me. Thank you very much.
Now it is time for questions to Dr. Walker. Any questions from audience?
Yeah, you told me you'd ask me one. Just kidding. If anyone has any questions, I will be around the whole conference, so.
Thank you for the nice talk. You mentioned almost of your talk is about the green mature fruit. Would it be also applicable to the red dry pepper harvesting?
Yes, so it would. So really as I said, we did test a lot of the double helix machines that are already being used successful in red chili, and they do work okay on green. It's something I didn't emphasize here, but I will say that the type of double helix machine does matter a lot. So it seems like machines that work well on red will do okay on green, but not as well as they do on red. They tend to break up green more than they should. And with our red chili crop, since it is dehydrated anyway, the harvest can take a bit of beating up, a bit of damage. But I know we check, many double helix machines. It just amazed me the difference we would see from this one to the Edgar machine. It was just, we got such a higher percent of undamaged fruit with the machine we settled on. And I know Elon is going to do the next talk, so he can talk about his equipment.
One last question.
Do you have any plans to cross Odyssey with any other chili peppers, perhaps to give it more heat?
Yeah, excellent question. No, actually increasing the heat of it is not something. It has been crossed with many, many other varieties, both by myself, my colleague at New Mexico State University, Dr. Dennis Lozada, I believe has. So with my program, no. And I guess I will say the reason we focused on the low heat is because the vast majority of the processed green chili in New Mexico is very, very mild. But I know that there's certain people, yourself, myself, who like more heat. So I believe Dr. Lozada is going to speak tomorrow, so you could ask him about it. But I know that we've crossed it with many things, and many of my colleagues have crossed it with many things. And we want to keep those mechanical harvest attributes, increase the heat. We are working on increasing disease resistance. So we're actively working to get Phytophthora chili wilt, Phytophthora capsicum resistance, because that was one of the real serious diseases that we have in New Mexico. Okay.
Thank you.
Thank you. Thanks.
Now I request